Hi, it's Paul. Here we're looking at endometrial cells. So these are even less common than endocervical cells, but they're gland cells too, so they tend to form fairly cohesive groups of cells. You can see this is a good example that they're much more tightly packed than endocervical cells. So here I'm focusing up and down on this group a little bit, and you can see there's overlapping nuclei here. It's not organized in a flat sheet where everything's in focus at once like the endocervicals were. Also notice here's quite a bit larger group, and so you can see there's a lot less cytoplasm on these cells. If I focus up and down here, you'll see that there's probably 3 cells deep in this group. This little dotty material I can see lying on top of the group as well is apoptotic debris. So remember, the endometrium breaks down by a process of programmed cell death or apoptosis, and that's the product of that. So it's just bits of broken down chromatinic material. Notice no honeycomb, or even if I look down this bottom edge, any palisading of the cells. So they're less obviously columnar cells, they have less cytoplasm than endocervical cells, and it's fairly indistinct. And again, I just can't see like a picket fence running along the bottom of that group at all. Notice this sample is got a lot of debris in the background, and this is broken down red blood cells. So these are frequently very bloody samples. The thinPrep lies it's quite a bit of that, but you get left with this debris if it's a very bloody sample. And these are usually menstrual products, so they're usually quite bloody. Here you can see the really loose group of endometrial cells. Notice these are a little more oval or elongate shaped. Notice the great chromatin on these, which we would call stippled. So as well as having a fine background to the chromatin, you can see dots of chromatinic material as well, like someone's shaded it in with dots. Notice the nuclei are overlapping here, and the cytoplasm has no distinct borders to it at all. Where my arrow is at the moment, these are red cell ghosts, and they're just the membrane of red cells that have been lysed. Now this is a typical exodus, which is an arrangement that we see early on in the menstrual cycle of endometrial cells that have been exfoliated. So around the outside we have cells that have a bit more cytoplasm, and these are considered to be endometrial epithelial cells. In the middle we have a much more tightly packed material, including some apoptotic debris, and that is stromal cells. So in summary, endometrial cells form quite crowded three-dimensional groups that are disorganized. Either that or they are present in exodus early on in the menstrual cycle, and that's that double contoured arrangement. Nuclei are usually quite uniform in size and roughly equivalent to the size of an intermediate cell nucleus. They tend to be round, oval, or a little elongate sometimes, and the classic thing they have is a stippled chromatin pattern. Some people describe that as salt and pepper, which I think is because they think there are small particles and larger ones. Nucleoli are not usually a feature of endometrial cells, although all gland cells can have small nucleoli. Cytoplasm is a lot less obvious than in endocervical cells, and there's a lot less of it, and it tends to be finely granulated with a fairly indistinct cell border like an endocervical cell. In summary, endometrial cells are much less common than endocervical cells. They should only be present up to day 10 of the menstrual cycle, shouldn't be seen at all in postmenopausal patients, and they're frequently accompanied by blood because they're a menstrual finding. The cell groups are easily told apart from endocervical cells usually because they're much less organised, no honeycomb or palisading. Occasionally you get groups of stromal cells that can look very similar to histiocytic cells, and we'll talk about